Welcome to Audio Abed, your gateway to the fascinating world of data science and machine learning. Whether you're a seasoned tech enthusiast, a curious beginner, or someone exploring the impact of AI in everyday life, this is the podcast for you. Join us as we dive deep into groundbreaking technologies, share insights from industry leaders, and simplify the complex concepts shaping the future of innovation.
Welcome back, everybody, for another deep dive. This time we're going to be tackling something that I'm sure is on a lot of people's minds these days. Is AutoML going to make data scientists obsolete?
It's certainly a question that's generating a lot of buzz.
Yeah, it seems like everywhere you look, you see headlines about AI taking over jobs and whatnot. But is it all hype? Or is there something real to be worried about?
Well, there's definitely some substance behind the hype, but I think it's important to remember that AI is still a tool, and like any tool, it can be used for good or for bad.
Right, so the real question isn't whether AI is going to replace data scientists. It's how data scientists can use AI to their advantage.
Exactly. And that's what we're going to be exploring in this deep dive. We're going to be looking at the rise of AutoML and what it means for the future of data science. We've got some great material to work with today, including insights from the book Automated Machine Learning and some real-world observations from the Generative AI report.
I'm really excited to dig into this. To be honest, I don't know a whole lot about AutoML. I've heard the term thrown around, but I'm not really sure what it is or how it works.
Well, in the simplest terms, AutoML is the process of automating the tasks involved in building machine learning models.
Okay, so instead of having a data scientist manually select algorithms, tune hyperparameters and all that stuff, AutoML can do it for them.
That's the idea.
So that sounds like it can save data scientists a ton of time and effort.
Absolutely. And it can also lead to better results because AutoML systems can explore a much larger space of possibilities than a human data scientist ever could.
Okay, so I'm starting to see why people are getting so excited about this. But if AutoML can do all this, what does that mean for the role of the data scientist?
That's the million-dollar question, isn't it?
Yeah, it kind of feels like we're heading towards a future where data scientists just sit back and watch the machines do all the work.
I don't think it's going to be quite that simple. While AutoML can certainly automate a lot of the tasks that data scientists currently do, it's not going to replace human expertise altogether.
So you're saying that data scientists are still going to be needed even in a world with AutoML?
Absolutely. In fact, I think the demand for skilled data scientists is only going to increase as AutoML becomes more widespread.
That's interesting. Why is that? I would think that if machines are doing all the work, we would need fewer data scientists, not more.
Well, think about it this way. As AutoML becomes more sophisticated, it's going to be able to handle more and more of the routine tasks involved in building machine learning models. That means that data scientists are going to be freed up to focus on the more strategic and creative aspects of their work.
So they'll be more like architects, designing and overseeing the overall AI strategy, rather than the builders who are actually putting the bricks and mortar together?
That's a great analogy. And just like a good architect needs to understand the capabilities and limitations of the materials they're working with, data scientists are going to need to have a deep understanding of how AutoML systems work. They're also going to need to be able to interpret the results of those systems and communicate them to non-technical stakeholders.
So it sounds like the role of the data scientist is going to evolve rather than disappear.
Precisely.
So that brings us back to the question of what AutoML actually is and how it works. We've talked about it in general terms, but I'm curious to get a little more specific. What are some of the different types of AutoML systems out there?
Sure. There are a lot of different approaches to AutoML, but some of the most common ones include things like hyperparameter optimization, meta-learning, and neural architecture search.
Okay, I'm going to need you to break those down for me a bit. Let's start with hyperparameter optimization. What is that?
Well, think about it this way. When you're building a machine learning model, you have to make a lot of decisions about how you're going to configure it. Like, what algorithm are you going to use? What are the learning rates? What about the regularization parameters? All of these things are called hyperparameters, and they can have a huge impact on the performance of your model.
Right, so if you choose the wrong hyperparameters, your model might not work very well.
Exactly. And that's where hyperparameter optimization comes in. AutoML systems can use a variety of techniques to automatically search for the best set of hyperparameters for a given problem.
So it's kind of like a brute force approach. The system just tries out a bunch of different combinations of hyperparameters until it finds one that works well.
Yeah, that's one way to think about it. But there are also more sophisticated approaches that use things like Bayesian optimization or evolutionary algorithms to search for the best hyperparameters.
Okay, so that's hyperparameter optimization. What about meta learning? What's that all about?
Meta-learning is a bit more complex, but essentially it's about learning how to learn. So instead of training a model from scratch for each new problem, you train a meta-learner that can learn from the experience of training lots of different models on lots of different problems.
So it's kind of like the meta learner is a teacher, and it's teaching the other models how to learn.
That's a good way to think about it.
Like,
And the advantage of meta-learning is that it can allow you to train models much faster and with less data.
that makes sense. And what about neural architecture search? That sounds pretty intense.
It is pretty intense. Neural architecture search is all about automatically designing the structure of neural networks.
Wait, so instead of a human data scientist designing the neural network, the AutoML system does it for them.
Right. And it can do a pretty good job of it, too. In fact, there have been cases where AutoML systems have designed neural networks that outperform those designed by human experts.
That's pretty impressive.
hmm
So it sounds like AutoML is already having a significant impact on the field of data science.
It definitely is. And I think we're just scratching the surface of what's possible.
Okay, so we've talked about some of the technical aspects of AutoML, but I'm also curious about the business implications. How is AutoML changing the way that companies use machine learning?
Well, for one thing, it's making machine learning more accessible to a wider range of businesses. In the past, if you wanted to build a machine learning model, you needed to have a team of highly skilled data scientists on staff.
Right, which a lot of companies, especially smaller ones, just couldn't afford.
Exactly. But with AutoML, you don't need to have that level of expertise in-house. You can use an AutoML platform to build models without having to write a single line of code.
So that's opening up a whole new world of possibilities for companies that previously couldn't even dream of using machine learning.
Exactly. And it's also allowing companies that already have data science teams to do more with less. They can use AutoML to automate a lot of the routine tasks, which frees up their data scientists to focus on more strategic initiatives.
So it's kind of like a win-win situation for everyone.
Yeah, I think so. And it's only going to get better as AutoML technology continues to evolve.
This is all really fascinating stuff. I'm starting to get a much better understanding of what AutoML is and how it's changing the world. But I'm also curious to know more about the potential downsides. We've talked about all the positive aspects, but I'm sure there are some challenges and risks associated with AutoML as well. What are some of those?
You're right, there are some challenges, and we'll dive into those right after the break. Stay tuned. Welcome back to our deep dive.
So before the break, we were talking about all the amazing things that AutoML can do.
Right, all the benefits.
But I think it's also important to talk about the potential downsides.
Absolutely. No technology is without its risks and challenges.
So what are some of the things we need to be aware of when it comes to AutoML?
Well, one of the biggest concerns is the issue of explainability, or the black box problem, as it's often called.
Black box. What do you mean by that?
So with traditional machine learning, you can usually trace back the decision-making process of a model. You can see which features are most important and how they're being used to make predictions.
Right, you can kind of peek under the hood and see how the engine is working.
Exactly. But with some AutoML systems, it's not so simple. The models they produce can be so complex that it's difficult or even impossible to understand why they're making the decisions they're making.
So it's like you've got this magical box that spits out answers, but you have no idea how it got those answers.
That's a good way to put it. And that can be a problem, especially in areas where transparency and accountability are crucial.
Like healthcare, for example, you wouldn't want a black box AI system making life or death decisions without anyone understanding how it's arriving at those decisions.
Exactly. And it's not just healthcare. Any field where there are high stakes involved, like finance or criminal justice, needs to be very careful about using black box AI systems.
Okay, so explainability is one challenge. What are some other potential downsides of AutoML?
Another issue is bias.
Oh, right. We were just talking about that earlier with traditional machine learning, how biased data can lead to biased models.
Exactly. And the same thing applies to AutoML. In fact, the risk of bias might even be higher with AutoML because the systems are often designed to optimize for accuracy without necessarily taking fairness into account.
So you could end up with an AutoML system that's really good at making predictions, but those predictions could be discriminatory or unfair.
Precisely. So it's crucial to be very careful about the data that you're using to train these systems and to make sure that you're monitoring them for bias.
So it sounds like even though AutoML can automate a lot of the tasks involved in building machine learning models, it doesn't eliminate the need for human oversight.
Absolutely not. In fact, I would argue that human oversight becomes even more important in an AutoML world. Data scientists need to be able to understand how these systems work, how to interpret their results, and how to mitigate the risks associated with them.
Right. It's not just about building models anymore. It's about understanding the implications of those models and making sure they're being used responsibly.
Exactly. And that brings us to another challenge, which is the potential for overfitting.
Overfitting. Didn't we talk about that earlier too?
We did, and it's a particularly relevant problem in the context of AutoML.
How so?
Well, AutoML systems are designed to find the best performing model for a given data set. But sometimes, in their quest for optimal performance, they can end up overfitting the data.
Meaning that they learn the training data so well that they don't generalize well to new data.
Precisely. And that can be a real problem because it means that the model might not work as well in the real world as it did in the lab.
So how do you prevent overfitting in an AutoML setting?
Well, there are a few things you can do. One is to use techniques like cross-validation to make sure that the model is being evaluated on data that it hasn't seen before. Another is to carefully select the features that you're using to train the model. And of course, you always want to have a human data scientist in the loop to make sure that the model is making sense and that it's not just memorizing the training data.
So it sounds like even though AutoML can automate a lot of the work, it still requires a good amount of human expertise to make sure that things are done right.
Absolutely. AutoML is a powerful tool, but it's just a tool. It's up to humans to wield that tool responsibly and ethically.
Okay, so we've talked about some of the challenges and risks associated with AutoML, but let's shift gears now and talk about the potential benefits. We've already touched on a few, like increased efficiency and accessibility, but I'm curious to hear more about the specific ways that AutoML is being used to solve real-world problems. What are some of the most exciting applications of this technology?
Well, one area where AutoML is already having a big impact is in image recognition. We're seeing AutoML systems that can identify objects in images with accuracy that rivals or even surpasses human experts.
That's pretty amazing. What are some of the practical applications of that?
Well, one obvious one is self-driving cars.
Rip.
AutoML is being used to develop the computer vision systems that allow those cars to see the world around them.
Right, so the car can tell the difference between a pedestrian and a stop sign, for example.
Exactly. And another application is in medical imaging. AutoML is being used to develop systems that can help doctors diagnose diseases like cancer earlier and more accurately.
Wow, that's incredible. So AutoML is literally saving lives. What are some other areas where AutoML is being applied?
Another big one is natural language processing, or NLP. We're seeing AutoML systems that can translate languages, understand human speech, and even write creative text formats.
So like chatbots, for example.
Exactly. And virtual assistants like Siri and Alexa, all of those are powered by NLP, and AutoML is playing a big role in making those systems more sophisticated and capable.
So it sounds like AutoML is having a pretty wide-ranging impact. What about the future? Where do you see this technology going in the next 5 to 10 years?
Well, I think we're going to see AutoML become even more powerful and sophisticated. We're going to see systems that can handle even more complex tasks and that can be used by even more people. And I think we're going to start to see AutoML being used in ways that we can't even imagine today. Like, for example, some people believe that AutoML could eventually be used to automate scientific discovery itself.
Wow, that's a pretty bold prediction.
It is. But I think it's within the realm of possibility. And that brings us to another really interesting question that I think we should discuss. What are the ethical implications of all of this?
That's a great question. We've talked about some of the potential risks of AutoML, like bias and overfitting. But I think it's important to step back and think about the bigger picture. What does it mean for society as a whole when we start to automate such a fundamental human activity as data science?
It's a question that we're only beginning to grapple with, but I think it's one that we need to be thinking about very carefully.
Welcome back to the show.
So we've spent a lot of time talking about the potential risks of AutoML, but what about the flip side? What are some of the ways that this technology could be used to make the world a better place?
Well, one area where I think AutoML has huge potential is in healthcare.
Oh, yeah, for sure. I mean, we've already talked about how it's being used to improve medical imaging, but I'm sure there are tons of other applications.
Absolutely. For example, AutoML could be used to develop personalized treatment plans for patients based on their individual genetic makeup and medical history.
So instead of a one-size-fits-all approach to medicine, we could have treatments that are tailored to each individual patient. Exactly. And that could lead to much better outcomes for patients.
That's amazing. What are some other areas where AutoML could make a positive impact?
Another area I'm really excited about is education.
Education.
How so? Well, imagine a world where every student has access to a personalized learning experience that's tailored to their individual needs and learning style.
That would be incredible. I mean, I think we all know that the traditional one-size-fits-all approach to education doesn't work for everyone.
Right. And with AutoML, we could create adaptive learning systems that can adjust to each student's progress and provide them with the support they need to succeed.
So instead of falling behind, students who are struggling could get extra help, while students who are ahead could move on to more challenging material at their own pace.
Exactly. And that could really level the playing field and give every student the opportunity to reach their full potential.
I love that. What are some other ways that AutoML could be used for good?
Well, another area that's really important to me is environmental sustainability.
Okay, yeah. Climate change is obviously a huge challenge facing our planet. How can AutoML help with that?
Well, for one thing, AutoML can be used to develop more efficient energy systems. Like imagine a smart grid that can automatically adjust energy distribution based on real-time demand and supply.
That would be awesome. So we could reduce our reliance on fossil fuels and transition to a cleaner energy future.
Precisely. And AutoML can also be used to monitor and protect our natural resources.
Like using drones equipped with AI-powered cameras to track deforestation or monitor wildlife populations.
Exactly. So there are a lot of really exciting possibilities here.
I think what's really striking about all of these examples is that they're not just about making things more efficient or profitable. They're about using technology to address some of the most pressing challenges facing humanity.
That's right. And I think that's what makes AutoML so exciting. It's not just a cool new technology. It's a tool that has the potential to make a real difference in the world.
I completely agree. Well, we've covered a lot of ground today. We've talked about what AutoML is, how it works, the potential benefits and risks, and some of the exciting ways that it's being used to solve real-world problems. I think it's clear that AutoML is a powerful technology that's going to have a profound impact on our lives in the years to come.
Absolutely. It's a rapidly evolving field, and I'm excited to see where it goes from here.
Me too.
Yeah.
And for our listeners, if you're interested in learning more about AutoML, I encourage you to do some research and explore some of the resources that are available online. There's a ton of great information out there. Thanks for joining us on this deep dive into the world of AutoML.
See you next time.